Welcome to class. In our lesson today, we are delving into basic geometry and, in particular, the finding the coordinates of the circumcenter of a triangle. Now, an example is on the board. So let's look at the question. We are given a circle that circumscribes a triangle ABC with the coordinates seen on the board. We are asked to find the coordinates of the circumcenter of the given triangle and the radius r of the circle. What do? We begin by saying let O be the circumcenter. So if O is circumcenter, we need to remember that because O is assumed to be the center of this circle, it means that OA is a radius of this circle which is equal to OB and also equal to OC. So to find the circumcenter, we want to equate the distances of OA and OB and also equate OB to OC. Thereafter, we find the value of R. So R squared is equals to OA squared, which is equal to OB squared, which is also equal to OC squared. And if you look at the coordinate of A from O using distance between 2 points, we say that this will be equal to x minus 5 squared, then plus y minus minus 1, y minus 1, which will become plus. Then this should also be equals to the right hand side. Let's look at OB. That is x minus minus 1 squared plus y minus 5. Y minus 5 all squared. So equating these two sides like this, we need to expand the brackets therein. And so expanding these brackets, we are going to have x squared minus 10x plus 25. Then here we'll have y squared plus 2y plus 1 because this will become plus. On the right hand side, we'll have x squared plus 2x plus 1. Then this will have y squared minus 10y plus 25. So if you collect terms by using the additive inverses, we will lose x squared and x squared will lose y squared and y squared, 25 and 25, 1 and 1. And what are we going to be left with? We are going to have negative 10x plus 2y is equals to 2x minus 10y. And at this point, if you collect terms using additive inverses also, to have the x terms on the left and the y terms on the right, we are going to have negative 10x minus 2x is equals to negative 10y minus 2y. And so giving us negative 12x is equal to negative 12y, which implies that r squared in this case will show that x is equal to y. So if we have x to be equal to y to be called equation 1, let us at this point also equate OB to OC and see what this will give us. So for OB is equal to OC because this is the radius of the circle using distance between 2 points. We have x minus minus 1 plus y minus 5. So we have x plus 1 squared plus y minus 5 squared is equals to OC, that is x minus 6 squared plus y minus 6 all squared. And expanding this, we are going to have x squared plus 2x plus 1 plus y squared minus 10y plus 25 is equals to x squared minus 12x plus 36 plus y squared minus 12y plus 36. Okay, at this point, collecting terms using additive inverses x squared and x squared, y squared and y squared. So what is going to be left? We are going to have 2x minus 10y then plus 26, because 1 plus 25 is 26. And on the right hand side, we are going to be left with negative 12x minus 12y. 36 plus 36 is 72. Hoping that you've copied this, I need to wipe out the top that we have already written so that I can continue writing. So look at what we have. If you collect the terms on the x to the left hand side using additive inverse, and that of the y to the right hand side using additive inverse, we are going to have 2x. Then this become plus 12x. And then on the right hand side, we are going to have negative 12y, and this become plus 10y. Let's look at the real number. Then we have a plus 72, and this become negative 26. So that we now have 14x is equal to, this will give us negative 2y. This minus this will give us plus 46. Okay, at this point, if we collect terms, the additive inverse of this become positive 2y, so that we have 14x plus 2y, 2y is equal to 46. And recall that from our equation 1, x is equals to y. So if we now plug in x in place of y, we are going to have 14x plus 2x is equal to 46, which implies that 16x is equal to 46, and x will be equal to 23 over 8. Since x is equal to y from our equation 1, it implies that the coordinates of the circumcenter of this triangle is going to be x comma y, which is equals to 23 over 8 comma 23 over 8. So at this point, we need to find the radius of the circle, which is the second part of our question. So before I proceed to finding that radius of this circle, I want to remind you to subscribe to this video, to like the video, to share it, and also make comments so that we keep on expanding this work for as many persons as possible to learn geometry in mathematics. So let's continue. Remember, we established the fact that the distance from the center of this circle to a vertex A is the radius of this circle. So if we say that r squared is equal to OA squared using distance formula, we can say that this is the same thing as saying x minus 5 squared plus y minus 1 all squared. So, and this would be the same thing as saying x minus 5 all squared plus y plus 1 all squared. And since x is equal to y, and then x and y are both equals to 23 over 8, so we can plug in 23 over 8 here, so that we have 23 over 8 minus 5 all squared plus 23 over 8 plus 1 all squared. Okay, so if you simplify this fraction by adding it, by subtracting -5 from it, 5 times 8 is 40. So we want to have 23 minus 40, and that will give us negative 17 all over 8 squared plus something here. That will be 8 plus this will give us 31 over 8 all squared. And if we square this, we are going to have 289 over 64 plus, if we square 31, we are going to have 961 over 64. Okay, I want to simplify that here so that our r squared, if you add these two fractions together, we are going to have 1250 over 64. Taking the square root of both sides, our r, we know that 1250 is the same thing as 625 times 2. So taking the square root of both sides, we are going to have 625 times 2 all over 64, which is the same thing as saying 25 root 2 all over 8 units. So this is the radius of the circle that circumscribes this triangle. Thank you so much for watching, and then leave comments on the page so that we can improve upon our video. Thank you so much.